Hey guys, Mr. Barnes here again. I just want to take you through some multiple choice. This is actually from an assignment that we did earlier this year. And I'll take you through the multiple choice on it, and you can use that for your studying. So this first multiple choice asks us, what is the transformational form of this equation, which is in standard form? So the first thing we got to do to convert to standard form, or from standard form to transformational form, is take this minus 6 across to the other side. So it's y plus 6 is equal to negative 2, and then 3x, oh, I forgot my cos. So I got negative 2 cos 3x plus 180. So then what I'm going to do, I'm going to divide both sides by negative 2. So that's going to become a negative 1 over 2 outside here. So immediately, these are gone. Okay, it's got to have negative 2 on the side, so it's going to be y plus 6 is equal to cos. So we also can't have anything next to the x. Look at these two. They both have 3 factored out of them, so I'll take the 3 out. I'm left with x. And what you had to do is recognize that you're dividing this by 3 now. You just divide that by 3, so it's plus 60. And I always say the easiest way to check and see if you got that right is multiply back through. So 3 times x is 3x, 3 times 60 is 180, and we're done. It's this one. Okay? So be really careful about that one. Alright, next one. Let's see. So we got, what is the equation of the sinusoidal axis of the image of y equals cos x transformed by the mapping rule? So the mapping rule, so you remember your sinusoidal axis is always the VT. So this is your VT here, and it is minus, so the VT is equal to negative 3 over 4, and your VT is always your sinusoidal axis, so the answer for that one would be B. Alright, so far so good. What is the period of the function? And here's the function. So you got to remember, in order to find the period, we need the HS. So the period is equal to HS times 360. All right. So my HS in this case is 1 over 4. So it's 1 over 4 times 360. And of course, that gives me 90. Okay, now this formula here is just a rearrangement of the one that we know. HS is equal to period over 360. Okay, that's just a rearrangement. I cross multiplied there to get my period equal to. So don't be fooled by that one. Alrighty, this particular question is a couple people asked me about this today in class when we had the study hall. Is how do you find the range when you're given the function? So what you need to find is your VT and your VS. The VT, of course, is your sinusoidal axis. Your VS is your amplitude. So what you essentially have here, this is your sine function. You have this. So your range is the distance between the maximum and the minimum. So this is your minimum here. So that distance is just going to be your sinusoidal axis plus your amplitude, or plus your VS, and then your sinusoidal axis minus your VS. Okay, so if my VT here is going to be 9, and my VS is going to be 4. Okay, remember, your VS is always positive. Don't be fooled by that negative. So we go VT minus the VS, which is going to be 9 minus 4, which is going to be 5. That's going to be my minimum. My VT plus my VS, which is 9 plus 4, which is 13. So that's going to lead me to this one right here. Okay, so that will be my answer for that one. Alrighty, next one. So we got the graph of y equals cos of x is transformed so that image has a horizontal translation of 45 left, so that'd be negative. So we're looking for a negative here of a horizontal translation. So this one is gone, and this one is gone. So it has a period of 180. So That makes my HS is 180 over 360. So that's 1 over 2. And then that's 1 over 2 here. This is not. Okay. Has an amplitude of 6. So that makes my VS 6. So just checking out and make sure we got everything else in line here. And a sinusoidal axis of -1. That, of course, means my VT is equal to -1. So that is the only possible one here that fits that description. Okay, so you could have stopped that, though, but I just want to make sure that you guys saw everything else that was in that problem. All right. Next question. There's only 10. Which graph is the graph of 2y equal to cos 3x? So we can get a couple of things from this. My VS is equal to 0.5. Okay, you flip that, so 1 over 2 or half, and that's my amplitude. And from this, my HS is equal to 1 over 3. So I got HS is 1 over 3. That also means my period of my graph is 1 over 3 times 360, which is going to be 1 over 3, or sorry, divided by 360, 1 over 3 divided by, so 120. Alrighty, so now we're looking for a period of 120 and an amplitude of 0.5. So the easiest thing to pick out first might be your amplitude. Look at this. Our amplitude here is 2. Done deal. Not what we want. This is a possibility. So let's check out our period. So again, period is the distance from max to max, or min to min, or from this point all the way across to here. So you got to be pretty careful of this. So we got a period we got an amplitude of a half, and it looks pretty close on there that it's 120. So we're going to give this one a nod. Now let's just check the other ones to make sure. This one has an amplitude of a half, but if you look at this period, it's way over, so that's definitely not it. And this one has an amplitude of 2, so yeah, we're happy with B. So maybe the graph wasn't, perfect on that one scale, but we still could have been confident with that if we stopped there. All right, this is a common one as well. Which statement best describes a graph? Periodic and sinusoidal. It's periodic, but it is not sinusoidal. Sinusoidal always looks like this. Okay? It looks exactly like every single sine and cos function, just like y is equal to sine of x or y is equal to cos of x. They all look the same. Your period might change, your amplitude might change, but it looks exactly the same. Periodic but not sinusoidal. This thing is definitely periodic, but it is not sinusoidal. So that's our answer. Okay? There's no such thing as sinusoidal but not periodic. That will never be the answer. Okay? What is the amplitude of this thing? Where the VS is equal to the amplitude, and my VS is 1 over 7, never negative, and we got to flip it. Done deal. The graph below shows the height of a nail on a water wheel with respect to the water. What is the radius in meters? So one way we can do this is we can think of the wheel itself. So it starts off here. So that would represent its, well, actually, let's start at a max. So this is the top of the wheel. It goes down halfway, and we're at this point right here. So we're down to here. And then we go a little bit further. We're down. Now we're at the bottom, the minimum. Then we're back up to here. And then we're all the way around. So if we think about that radius is just going to be our amplitude. So it's going to be 2, 4, 6. So our amplitude is 6. And that is our radius. Okay? Last one. What is the horizontal stretch for the graph shown below? So HS is period over 360. Only got 18 minutes left. Better hurry up. So let's see. We got period. So it goes from 0 over here to 8. So it's 8 divided by 360. So 8 divided by 360. It's going to be in fractional form 1 over 45. So that is my HS. Weird answer, but that is it. All right. Hope that helped you guys. If you got any more questions, feel free to email me. Thank you.